All right, welcome everybody to Loops Day 2. And so we are going to write a program today that is going to compute the batting average and the on-base percentage for a baseball team. And we're going to do that by entering all of the hit, walk, and out data for each player. And then we're going to compute the stats for each player, and we're going to compute the stats for the team. And one of the really important things in computer science is learning how to break a problem down. Right? There's a real tendency in new programmers especially to just try and write everything all at once from scratch because they don't know how to like build from a small working core upwards. But that's always the approach you should take when writing code. You should not be trying to code the entire solution all at once. It's a recipe for disaster. You forget a curly brace somewhere and then just nothing works and you've got 100 lines of code and what you need to do is start with something small that works, that you can test, and once you're confident that little bit works, then you add a little bit more, and you test the hell out of that and make sure that works, and then you grow it a little bit more and test the hell out of that. And by testing the hell out of it, I don't just mean testing to make sure it works when you type in good data, but also type in wrong stuff, type in negative numbers, type in zeros. There's all sorts of different ways that you can break a program. Type in nothing. That's another way. You can oftentimes get a division by 0. And so every time you test it, try the good, the bad, and the ugly. Sorry, the good data, bad data, and then edge cases. Edge cases fall right on the boundary between good and bad, like a person who gets no hits, or a person who gets no walks, or a person who gets no outs. Make sure it works for each one of those cases. Do people still use paper to write code? I mean, I guess. There's people who use flowcharts to write code too. There's a lot of different ways to do it. But basically, you need to start small, go slow. Okay? That's the approach. So rather than trying to do this whole thing for the team and all this kind of stuff, we are going to start by just asking a couple questions. First of all, should we use a for loop or a while loop? We're gonna do one player first, then worry about the team stats later. Okay. So for one player, we're gonna enter all of their hits, walks, and outs. Do we use a for loop or do we use a while loop using the schema that I have taught y'all? Technically, you can use anything for anything, but a for loop, okay? So for int I equals 0, I is less than what number? I plus plus. So how many at-bats is a player going to have in a season? $300? Exactly 300? Every time they have 300 at-bats? What if they get injured early on? How do we know how many at-bats they're going to have? A variable at-bats, so you know in advance how many at-bats they have. You can do that. Personally, I would use a while loop. Every player is going to have a different number of at-bats, and we don't have to count in advance. So every player is going to have a different number of at-bats, and we'll just let the user type in hit, walk, out, quit, and then it's done. Okay. So what variables do we need? How many variables? Variables maintain information about something, right? In this case, we're keeping information about a player, a baseball player. The three things that we're worried about apparently are hit, walk, or out. We could break this down further detail with single, double, triple, home run. Get beamed, by the pitcher. Just put a variable at bats there. Okay. So we do an int at bats. Okay. Initialize to 0. Is that the only thing we need to track? The user's going to type in hit, 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 quit, and then we need to say they've added 1,000, right? Okay, keep track of hits as well. All right. What else? Okay. So we're going to read a word from the user. If s is equal to hit, then we need to say hits plus plus, and also your at bats plus plus. Else if s is equal to walk, walks gets incremented, at bats gets incremented. Otherwise, if we type in out, outs plus plus, at bats plus plus. Otherwise, cling D server crashed. Good job, cling D server. You're my favorite. Equals quit. Then we break. Remember, this is an infinite loop. That's an infinite loop. Every time you have an infinite loop, this is the way out of the infinite loop, right? So what we've written here is code that'll run forever. It'll keep going forever and ever, asking, do you want to hit, walk, out? You punch it in, you punch it in, you punch it in. It'll run literally forever until the user hits quit, in which case break cancels the loop. This code design is very, very common in computer science, where it's like you're kind of running until something happens, right? And you can just put a break anywhere within there, and then that terminates the loop, and it will come down to here and keep running after the close curly brace here. Okay, so let's just test this code. Let's just see out hits, walks, outs, at bats. Okay, so we got some working code here, and we're gonna do hit, 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 walk, out, walk, quit, and so we got 3 hits, 2 walks, 1 out, and we had 6 at bats. So looking pretty good to me. All right, so let's test it. Quit. All right, 0, 0, 0. All right, that's handled properly. What if we type something else? We should probably handle that. So if it's none of the above, else, I don't know, just see out unknown command. Please try again. All right, so it's probably a good idea to handle that a little bit reasonably. Okay, and what if we broke the input? What if not cn, right? It crashes. Okay, so yeah, say if not cn or they hit quit. So if something causes cn to explode, we'll just print our stats and be done. Yep. Infinite loop. Do you guys see this? Do you understand the structure of this? So this pattern here is a pattern that you will see over and over again, where you've got like a menu of items. And in a modern computer program, it's not going to be a text output. It's going to be a list of different things, like you go up to a menu or something like that, and you select from it. Somewhere within there's going to be code like this. There's going to be some list of options, usually in something called an enum, which you saw without explanation in the triangle tester assignment, that lists all the different options that are available. And then somewhere there's going to be like an if, else if, else if, else if, else in there to handle it. Okay, so I think this is looking pretty good. So what's the next thing we need to do? What do we want to do next? We want to print the stats for the baseball player, right? How do we do that? How do we compute the batting average? Let's say. I'm asking you. How do I do a batting average? Times at bats versus hits. Hits divided by at bats. Okay, let's give that a shot. Hits divided by at bats. Okay, so we'll get 1 hit, 1 out. So we had 1 hit, 1 out. That's 2 at bats. Our batting average was 0. Sad trumpet noises. So we divided hits by at-bats and we got 0. This is why we always test our code rather than assuming it works. What went on here? What's the problem? What's the issue? Why do we get 0? Integer division. Okay. So we could fix this by making at-bats and things like that floats, but then there's a possibility when we add 1 to it, we had 0.99 and not 1, and that's a problem, maybe. So one approach we can take is to actually convert one of these numbers to a float or a double. And we can do that by 3 different ways. We can do that, and that will convert at-bats to a double. So if it was 2 before, it'll be 2.0. And if you mix an integer with a double, you get a double division instead of integer division. Right, so that's one way you can do it. Another way you can do it is like this. That works fine. Not recommended though. This is the old C way of doing it. This is how the C programming language does casting. Casting is when you convert from one type to another. So this will convert at-bats to a double. It looks a little weird. Looks like you might have an order operations issue. So it's probably better to do it this way where it looks like a function. The official recommended, blessed by the C++ core guidelines is to use static cast. So static cast is a function whose sole purpose is to convert from one type to another. So in this case, it is going to convert an integer to a double and return the double equivalent of at-bats. It's far more verbose. I don't use it personally that often because it's a lot more typing than just typing double parentheses at-bats. But if you want to be maximally correct and have Bjarne Strustrup look down upon you with blessings, this is the proper way of doing it. Does it help with accuracy? Nope. All 3 of them will compile down to exactly the same code. The reason why does it go back to being an int after that line? Yeah, it doesn't change the variable's type. What happens is it's a function that returns a value that is the double equivalent of the parameter passed in. Although it actually arguably doesn't even do a function call as such. So yeah, it does not permanently change at-bats into a double. Good question. It is at-bats is still an int. It's just for the purpose of this division, it is going to be a double. Static cast converts from one type to another. So you can convert from an int to a float, or a float to an int, or an int to a double, or double to an int. It doesn't work on strings. So hit out. There we go. So we got a batting average of 0.5 now. So this converts static cast converts from one type to another. Okay. And so this makes the denominator a double, and we do that. However, we're not really getting what looks like a batting average, right? We're getting 0.5 when we kind of want to say 500. You guys have ever seen baseball? It's always 3 digits. So there is a there's a thing called setprecision, like that will give you 3 digits of output. If you want that, you need to do this, include iomanip. Iomanip gives you access to set precision and fix, which we'll show in just 1 second. So what you do is you actually echo to cout set precision 3. And there's a little bit of like C++ magic going on behind the scenes here. It actually doesn't echo anything to the screen. What it's doing is that it's setting the number of significant digits for scientific notation numbers like doubles and floats to be 3. So it's always going to show 3 digits after the decimal with that, which is what we want. Except it doesn't always, as we'll see. So if we go hit, out, get 3 digits, 0.333, cool, awesome. Hit, out, still getting 0.5. The reason for that is by default it won't draw trailing zeros. So we can draw trailing zeros by enabling what's called fixed point mode. Fixed point mode can be enabled like this. And that means it will always draw 3 digits of precision. Okay. So if we do this, go hit, out, we get batting average of 500. So good, it's looking good now. So let's test it some more. Like I said, you should always be testing these things. So hit and walk, quit. Ooh, our batting average is 500. I don't know if you guys know baseball, but that seems a little fishy to me, right? Like if you got hit once, if you got 1 hit, and you got a walk, that shouldn't lower your batting average. You know what I mean? So what's going on here? Our at-bats is 2. Why are we getting batting average of 500 if we're getting walked? Being walked should not lower your batting average. You know what I mean? What's the fix? What do we need to do differently here? Anyone play baseball? Do walks count against your batting average in baseball? Walks plus bats? Walks don't count for your batting average either. Hits divided by at-bats minus walks. That's one way you can do it. Another way you can do it is just by not having walks count for at-bats, right? So at-bats would only count your hits and outs. That's maybe a slightly cleaner way of doing it. You shouldn't increment at-bats when you walk. Yeah, exactly. Let's try that. So if we go hit, walk, out, quit, 3 hits, 1 walk, 1 outs. That's a total of 4 at-bats. And so we got 3 hits out of 4. So 750. Cool. Okay. What do you guys think? Is this code pretty good? Pretty solid? What do you think? Is this looking... Have we tested it sufficiently? Are there other ways this code could break? You guys have been vetting things for 2 straight assignments. What way could this code break? Just walks, yeah. Why? How would that break? How would that break our code? No, at-bats means division by 0. It absolutely does. Also, what if we just hit quit right at the beginning? Right? This is why I said, when you test your code, you can't just feed it good data. Like, oh, we'll do 1 hit, 1 out. All right. Yeah, 500. All right, it works. No, you can't just test the good. You got to test the good, the bad, and the ugly. Right? So let's just quit. Batting average, negative nan. Not a number. It's negative infinity. What if we do walk, walk? Walk. This is like the internal monologue of my dogs, you know. Quit. right? And once you've taken computer science, you'll see nans pop up everywhere. You know, you had a vending machine. It's like ice remaining nan. 0 divided by 0, or in this case, we're dividing 3 by, or yeah, 0 by 0. So, yeah, we need to like do something about that, right? So, we need to stop it from doing it in division by 0, right? Division by 0 is no bueno. So, cucumber, yeah. JavaScript has some interesting views on how algebra should work. So if @bats equals 0, then cout no batting average. Otherwise, did I leave something off? That. Otherwise, we will print out the batting average. Do you guys see that? Anytime you see a division, your first thought should always be, what if that denominator is 0? Could it be 0? In this case, yes, it can be 0 several different ways. If we have all walks, that's one way. If they just hit quit, that's another way. So, my high school calculus professor, he taught calculus at our high school for fun. He was a full-time engineer at General Dynamics, and his job was a NAN wrangler. His sole responsibility was to look through the source code for his company and numerical simulations. They were building fighter aircraft and stuff like that. Like they were, I believe, the people that built the F-18, and things like that. And they have a bunch of fluid dynamic simulations and air, flow simulations and things like that. And his job was to look for nans, for divisions by 0. And so every time he saw a division like this, he would look at it and be like, could it be 0? Could it be close to 0? Because being close to 0 is pretty bad too. Like if you divide by 0.01, then your number is going to explode into like the stratosphere, right? Like if you have a temperature that's like, or a velocity that's close to 0, you divide by like that, then you end up getting some unholy number, right? So he basically did this for a living. Every time he saw a division, you just stare at it and like look at it and be like, all right, could this number ever be 0? Could it ever be close to 0? And then you'd add in checks and things like that to prevent it from becoming degenerate. And he liked his job too. He was a decent calc professor. He was more of a programmer than a math guy, and I think that probably hurt my math skills overall, because he taught us how to write programs to do integrals instead of like solving them by hand. Like simple integrals you'd solve by hand. He's like, trust me, anything that's complicated in the real world, people write a program and they approximate it. So I'm going to teach you guys how to approximate integrals. And so I never learned how to like solve complicated integrals by hand. I would write a program on my calculator to approximate them, and it's kind of a good thing, bad thing, I guess. It's in my differential equations final, I'm sitting there. I wrote a differential equation solver during the final, and I was sitting there. Every time I hit enter, it would do one more approximation. Professor's like ready to leave. He's like, come on, you need to write in your answer. I'm like, it's converging, just wait. He's like, what are you doing? I'm like, I wrote a program to solve this for me because I can't do it numerically because I'm an idiot, but I wrote a program and it's converging. Look at the significant digits, they're getting better. Just wait. And he thought it was amusing, and he ended up just giving me a B in the class. It's like, yeah, you're kind of dumb when it comes to math, but at the same time, like that is what math people do. So, I don't know. I'll just give you a B and call it a day. He's like, what are you going to show for your proof? I'm like, I'll write the program down, and yeah, it was kind of ridiculous. All right, so so we got to check for nan. So we got that. That's looking pretty good, I think. All right, let's do on base percentage. So on base percentage, same thing. All right, how do we do it on base percentage? So if you get all hits and walks, that's 100%. How do we do it? How do we compute that? Batting average just ignores walks. Now we're going to include walks. Hits plus walks divided by at-bats. All right, let's give that a shot. Are we forgetting anything? Nope. Okay, let's do it. All right, hit, walk, out, quit. On base percentage of 0. Remember that one? Want no division by 0? I'm just throwing this check in, so we don't have to check for division by 0 twice, right? At bats of 0 is gonna check for both of them. So what is the why do we get a 0 on base percentage here? Yep, still got to do the conversion. We could do the at bats, or let's do the top part just to show you guys that we don't discriminate. We could static cast the top, or we can just do that if we want. Same thing. This will convert hits plus walks into a double, and it's the same thing as static cast double. Same thing. Converts to the same code. Now, you might ask why you would do this versus this. Anyone know? It actually doesn't matter if you do the numerator or the denominator, but why would you do static cast double versus double? Why would you do it? Good. Thanks for throwing me the underhand softball pitch. It only remains a double for that specific statement. Yeah, it's like a function that takes an integer in and returns the double equivalent of it. So it takes in 5, returns 5.0. It doesn't change the original value. It's just a function. These two things do exactly the same thing, but the C++ core guidelines recommend use static cast. Personally, I tend to use the second one there. I tend to use this one because it's less typing, and my speed is important. I optimize programmer time. I optimize my time. And the reason why you'd want static cast double is you could search for it. So if you wanted to find all cases in your code where you're converting to a double, you can search for static cast double. Whereas if you search for just like double, like that, then you're going to get every double, you're going to get millions and millions of hits because you have probably doubles throughout your code base. And so it makes tooling easier. It makes it easier to find every instance of when you're converting to a double. That's the main benefit, I guess. I don't know when I've ever searched for every instance of converting ever. But that's the reason given by the core guideline authors. Wouldn't you want to double at bats instead of hits and walks? It doesn't make a difference. If either side is a double, then it will do double division rather than integer division. Either side, it's actually fine. You could probably argue about integer overflow or something. I don't know. Probably not a big deal, at least for our purposes. If you have over 2 billion hits and walks, like you've probably got a bigger problem than you know what I mean? Like that's a hell of a baseball season to get 2 billion hits and walks. You know. Okay, so yeah. All right, let's see if this works. So we'll do a hit, we'll do a walk, and do that. Our on base percentage is 200%. Uh-oh. Our batting average is 100%. 1,000, sorry. Yeah. Batting 1,000 is 100%. Our on base percentage is 200%. So we get on base twice for every time we go to bat. Okay, there's clearly something wrong here. So what is our problem? Why is our math wrong? And do you guys see why I'm taking this like one line of code at a time, right? And testing it and vetting it, right? What if we have a walk just by itself? No on base percentage, really? No on base percentage. I got on base. I had a walk. Something's going on here, right? Have a walk and an out. My on base percentage is 100%. My on base percentage was 550%. So, yeah, we're gonna need to factor in walks, right? Because our at bats number is just not counting walks now, so we need to add walks back in. And if you're like, but wait, I thought we just removed it from up here, and the answer is yeah, we did. And you're like, but okay, what's the best answer? And the answer is I don't know. Like, should we include walks and at bats and then subtract it out? Or should we not count walks and at-bats and add it in? Right? When we did this in the previous class, we didn't compute at-bats at all. We just didn't use it. So, you know, we just held on to these numbers here. And then rather than using at-bats, we just said hits plus outs here. And down here, it would be hits plus outs plus walks. So, I don't know. I don't know which is better. I don't know. What's more readable? I don't know. What's more understandable? I don't know. So, I'll just put it back. And then just factor in, here it's hits plus at-bats, here it's hits plus walks over hits at-bats plus walks. I don't know, maybe there's a little bit of symmetry there or something. Okay, let's try this. Okay, so one hit, one walk, one out, on base percentage of 667, good. Yep, 2/3. Walk by itself still doesn't work. How do we fix that? Obviously we have an on base percentage. How do we fix this? See what the problem is? Have to change the if statement? Yeah, I think so. So we're gonna have to pull this out. Alright, so if at bats plus walks equals 0, then see out no on base percentage, else see out on base percentage. One walk, no batting average, but we do have an on base percentage of 1. So we need to do the set precision again, because that set precision didn't get called, right? Because we skipped this line. This line got skipped because we had no batting average. That's why you need to test everything. Every possible branching and combination of branching that you can come up with, you need to test them. Okay. And you grow your code from the smallest little seed into the most beautiful tree, a little bit at a time. One walk by itself, good. No batting average, on base percentage of 1,000. Hit, walk, batting average of 1, on base percentage of 1. An out by itself, batting average and on base percentage of 0. Quit by itself. Hit, walk. Okay. It's pretty good to me. So what's next? What's next for us? We've got various stats being calculated. We've got different input being input. One thing that I would probably want to do is allow like the player to type hit instead of hit, you know what I mean? Or hit, you know what I mean? So, in order to do that, we need to uppercaseify a string. All right, so this is a very common task called uppercaseify a string. And so what you do is you loop over the string for every character within the string, set it to the uppercase version. There's a function in C++ called toUpper that takes a character that takes a lowercase a and returns an uppercase a. If it's not a lowercase letter, it just returns the letter. So what we're going to do is write a for loop for size ti equals 0, I is less than s dot size, I plus plus, s dot at I equals toUpper s dot at I. So this is starting at index 0 in the string, so if our string is like hello, index 0 is h. So it's going to convert hello into hello, like that. Okay. So the first time through the loop, I is 0, so it's going to grab the 0th character out of the string, which is capital H. It's going to call toUpper on it. The uppercase version of capital H is capital H. So it kind of does nothing. And then it moves on to I is equal to 1. When I is equal to 1, s dot at I is e, lowercase e. It calls toUpper on it. That sets it to capital E, and we save it back into the string like this. So it becomes capital E instead. And then we uppercaseify the L, the L, the O. The uppercase version of exclamation mark is just exclamation mark. It doesn't change anything unless it's a lowercase letter. And it doesn't change it directly. It's a function. It takes in a lowercase letter and it returns the uppercase version of it. And this is a function found within CC type. Okay. So iomanip gives us access to setprecision and fixed. And toUpper is found within CC type. It's also sometimes included by other things as well. In this case, we actually didn't need to include CC type, but it's probably best if we did. Okay. Any questions about this? Looks good. You guys understand everything that's going on here? You understand what the size t means? Can you do more than one character at a time? This loop is doing all of the characters, right? So it's looping over the string. If you want to do like a parallel loop, you could do like something like that. That'll parallelize the code for you automatically, but you don't need to worry about it. What does size underscore t mean again? It is a alias for an unsigned integer of some size. In this case, it's actually an unsigned long. And the reason why we need size t is because that's the type returned by string size. So you can't have a negative length of a string, right? You can't have a string of length -5. So it returns an unsigned integer. And C++ will yell at you if you mix signed and unsigned integers together. It's not an error. It'll work if you are happy with integer. You can do integer. It will yell at you though. That's because when you compare signed and unsigned integers, they don't work outside of the 0 to 2 billion range. If you have a regular integer, it's negative 2 billion to positive 2 billion. Unsigned integers are 0 to 4 billion. So in the 0 to 2 billion range, they work fine. That's why it's just a warning. And for a lot of your code, you won't notice any difference. But if you ever have like a -1 for the integer or over 2 billion for the unsigned integer, then your code explodes. So in this case, having an int there would be just fine. You wouldn't notice any difference unless the string was greater than 2 billion in size. But it's more proper to do it that way. And I like doing it because it shuts up the server. Okay, so just use size t. If you ever see that warning, comparison of an integer expression of different signedness, int, and stood : underscore cxx11. Yeah, C++ doesn't have the best warnings in the world. Int and aka long unsigned integer. So it's saying you're comparing a signed and an unsigned integer, which it'll work as long as the numbers are between 0 and 2 billion. It's just good to get into the habit of using size t though. One thing I did in the previous class that I found to be funny, system prints out a cool color banner every time you do it. One thing that Mr. Bell and I were looking at was so system is a function that runs a program on the server. So any Unix program could be run using system like this. And in this case, I'm banner printing. Figlet makes a little banner, and it's going to print statman 2000 to the screen and pipe it through lolcat. Lolcat colorizes it. So it's just kind of a fun way of doing a little thing like that. The system syscall, or is that syscall? No, it's probably in the standard library, is marked as something called no discard, which means that if you don't catch the return value on it, it gives you a warning. Warning: ignoring the return value of int system declared with attribute warn unused result. So it gives you a warning every time you do this because they really want you to pay attention to the return value. Something like that. So if the thing fails to run, you're supposed to handle it or something. So kind of annoying, kind of super annoying. Okay, it should not be marked as unused. The no discard attribute means if you ignore the return value of this function, you're doing something wrong. For example, if you call absolute value and you don't catch the return value to absolute value, there's absolutely no point to calling absolute value. So it should be marked as no discard, which means send a warning if they're not catching the return value. System, though, does something. It runs a thing. The return value is just sort of an unimportant byproduct. So it really should not be marked as no discard, in my opinion. I feel like I've seen worse type conversion errors working with other languages. Yeah. Okay. So what's next for us? So we're processing one player on the team. So what is our next step? We got to grow this program some more. We got 10 minutes left in class. What's our next step? We got a cool banner now. We're processing stats for a player successfully. What's our next? Compute for the team. Yeah, I think so. And for this one, we'll do it with a for loop, just because we did a while loop for the other one. So let me, stats for the team. So let me show you how you can nest loops inside of each other. And this is a very, 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 very common structure of a program. You have a loop inside of a loop inside of a loop inside of a loop inside of a loop. So, in fact, here we've got a while loop. inside of the while loop, we got a for loop, right? And then we got if statements and else if statements inside of a while loop. So all these control structures can nest inside of each other. And so that's why these curly braces are really important, because they show you where the control block starts and ends. And so this for loop is inside of this while loop. Now we're about to put this while loop inside of a for loop. So we're going to have a for loop inside of a while loop inside of a for loop. So you can loop while you loop while you loop. What's up, dog? I heard you like loops. So I put a loop in your loop so you can loop while you loop. Current I equals 0. I is less than some number, I plus plus. And then I'm going to jump down to the bottom of the while loop by hitting Shift 5. Shift 5, or the percentage sign, bloop, drops to the bottom. And I'm going to note that this is all part of the player stuff as well. So I'm just going to scroll down to there and put a close curly brace there. So now if I hit Shift 5, hit Shift 5, you see how it's jumping up and down between the two. So cool. And if you want to indent everything between the two curly braces, the double equals sign, this was asked in the previous class. How do you indent lines without like hitting tab and stuff? Greater than, greater than, greater than, greater than, greater than, greater than will right indent, less than, less than, less than, less than, less than, less than, left indent. I typically don't do those at all. I use equals equals. Equals equals will indent the line to wherever it should be. Now if you want to indent everything between the curly braces, I'm going to type equals Shift 5. Any Vim command can be combined with a motion command, mostly. And so equals is the auto indent command, and I'm going to combine it with a motion command to jump back up to the matching control brace. And you'll see that everything in between just indented properly. It's all been properly formatted. So that's the power of Vim in a nutshell. So we've got an issue here though, which is that should actually be per player. Which is how many players do we have on our team? Right? I told you that Vim's useful. And I know there are some students here who have not even done the Unix tutorial yet. Trust me, do the Unix tutorial. It will save you so much pain and headache. Like, I know there's a real resistance from some students to not do anything that's not required, you know? But trust me, it will make your life better. The URL for the Unix tutorial is on Canvas, and it also displays on the server every time you log in. And doing a Vim tutorial is probably worth it too. Okay, so equals a Okay, so how many players should we have? How many players are on our team? Well, one thing I actually want to show you guys also is I got sort of annoyed at how often I had to write 3 lines of code to just read in one value. And so I made a function that would do this. So you just say string s is equal to read. Just like that. And this line of code here does the same thing as these 3 lines of code here. So this is my read library, which I've won international fame and reputation. I've had a whole 40 people use it on GitHub. It's pretty amazing. So this string, this is going to declare a variable, and it's going to print to the user, please enter, hit walkout or quit. And if they type in something bad, if they screw up or something, it throws away the bad data, reprompts them. It's just a much more reasonable way of doing input than the way the standard does. It also recovers from errors automatically. Recovering from errors is a pain. And so you can just call this function here called read. It's provided by this up here. And it's also available on GitHub if you're at home and you want to use it on your home machine. This is not part of the standard library. This is a CSI 4X exclusive. Great. So how many players? I'm still asking this question. I'm not going to proceed onwards until you tell me. How many players should we have? Do we know how many players are on a baseball team? $25? $7? Do we know? I mean, on the field is one thing, but like on a team, you know? I don't know. Like, let's do what you suggested earlier, and let's just ask the user. All right, so let's just say int players is equal to read. Please enter how many players are on the team, like this. And then if they type in squirrel or something like that, then it will discard the error and reprompt and all that kind of stuff, which is really nice. And so we'll just loop once for every player. Thank you. That. So for every player, we're going to go through the stats. And now we need to compute team statistics, right? So we're going to need team statistics. Team at bats. We're going to need team hits. We need team walks. And team outs. Right? And so now we're going to ask how many players are there? 5. So we're going to input stats for 5 players. And then it is going to, we need to add in a little bit more here. So in addition to hits and at bats, we're going to add in team hits, team at bats, team walks, team outs, and team at bats. Okay. So we're not going to use those stats for the individual player statistics here, but after we're all done with all that stuff, now we're going to compute team statistics. Statistics. Did I spell that right? That's amazing. Okay. Let's just test this first. So how many players are on the team? 2. Oh, by the way, it's nice. 0.5, 2. Okay. So it clears the error, pulls the bad data out, reprompts it, and we'll keep doing that until you get an integer. When you call read, it will insist on getting an integer. So, okay, so for player 1, we'll have 1 hit, 1 walk, and quit. Look, we can type in lowercase now because we're uppercaseifying the string. Team person 2, he's a bad player, all zeros. Okay, so person 1, perfect player, player 2, horrible player. We need to compute the team statistics now, okay? So how do we do that? We got 3 minutes left. How do we do it? We got like 20 people in chat. I want to see some code coming out here. We got team hits, team walks, team at bats. What do we do? What's the best way of me writing this? That's how I get class participation. I just stare awkwardly at the students until they type something. I got coffee. I can do this all day. Okay, I'm out of coffee. Can't do this all day anymore. But I got iced tea. E2N. Good brand. At the end of each while, add the hits to team hits. We're actually adding up the at-bats for the team. All that stuff is just while we're reading the player data. We could probably be a little more efficient by just waiting till the end of a player and then adding in the hits to the team hits. That's true. It'd probably be a little bit faster that way. But how do we compute the stats for the team? So as we go along, all the team statistics are being gathered. You got 2 minutes left now. See out team statistics. Team hits, team walks, team outs, team at bats. Okay. So those are our variables to work with. We got 1 minute left. How do we compute the team statistics? We got 4 variables that have accumulated all of the statistics for the team into it. You can use similar code to compute the individual BA and OBP. Just use the team variables instead of individual. Precisely. Yeah. So in fact, I am just going to go into visual mode, type V, and I can just highlight all this stuff here and hit Y to copy. And we come down here and hit paste and hit paste. And I'm going to just add team at bats, team hits, team at bats, team at bats, team walks, team hits, team walks, team at bats, team walks, and we're done. Copy and paste with using Vim to quickly change things. 2 players, we're going to have player 1 be hit, hit, walk, out, and then quit. And then player 2 is just going to be terrible, out, 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 quit. And so we've got here a total of 7 at-bats, 5 outs, 1 walk, 2 hits. So yeah, there you go. You're so fast with Vim. Does the Unix tutorial cover it? No, the Unix tutorial is something separate. So there's a lot of good tutorials for Vim on there. There's a place called Vim Tutor that will run you through. It's working. So there's good guides to Vim. It's the kind of thing that you just start off just doing insert and typing and hitting escape and shift's easy, and then over time you learn more commands. Vim Tutor in the terminal will also do it. Yeah, Vim Tutor, Vim Tutor, like that. And so it's got lessons inside of there. There's also Vim Adventures, which is a little role-playing game that teaches you how to use Vim in a little top-down scrolling RPG. So, yeah, the more Vim you know, the faster you'll be. And this is why people that even people that use Visual Studio, they tend to install Vim mode, because it's so much faster to do stuff than if you have to do everything by hand. Okay, so that's it for today. We've got here we've got a loop for every player. For every player, we read in until they type quit. And every time they type in a command, we loop over their input. You might notice we have I twice. We've got I up here. We've got I down here. This is, in general, not recommended. So I'd probably want to change that to a J. It does compile, it does work because it's a shadowed variable. But it makes me nervous to see that. So if you ever have a loop inside of a loop inside of a loop, the outermost loop should be I, the next one should be J, the next one should be K, and so on and so forth. So this is what a program looks like. You start small, you grow it up. Okay. And you wrap loops inside of loops and put things inside of them, and you just sort of, as you get better at programming, your ability to comprehend and understand complexity grows as well. And so when you start off, you just write a few lines of code, and then over time, like, you can kind of encompass more and more in your brain at once. But don't try to write this whole thing from scratch, right? You don't want to try and do all of this at once. You start small, go slow, test, 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 fix, 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 test, 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 and build and build and build and build and build. And that's how you write good quality code. So that's it for today. We will pick this up on looks satisfying at this massive code. It's not really, how many, 85 lines of code. It's not really that massive. Copy main.cc up into public baseofall.cc. So if you want a copy of today's code, copy /public/baseball.cc to your current directory, and then you can gaze with wonder upon baseball stats code. Okay, no new programming assignment today. Nope. Work on your competency exam if you haven't done that. Work on the Zybooks due on Friday. You'll get your next programming assignment on Wednesday. Okay, that's it for today, guys. Thanks for coming out, and I'll see you next time. Peace.